and then I will go through this process, and that is why I am going to stand here and put my phone, but I will move a bit. So like last semester, student complained that the phone moves a lot, but I don't know what else can I do to keep the phone, because I have to go from here to this weighing balance room and then come back, then go there, come again here, take the water. So I will move a bit, so please bear with me. Just hold on, let me put my phone there. Please tell me, let me check if you can see. Okay. Hold on. Since my phone hang. Okay, no. So you can see my table now. Here. Okay. I will be working there.
Hi guys, did the teacher internet turned off or is it only me?
I think the
He's
internet
working.
crashed.
Yeah, I think the lab has bad internet also. Service.
Hello, can you hear me now? Hello?
Yes.
Oh, okay. I don't know what happened. So, okay, so you can see the table, my hands are here, right? You can see this. How do I know that if you cannot hear me? Just now I was describing my much, and then I realized that you could not hear it. So can you hear me now properly? Can you see my hands?
Yes.
Oh, good. So the titration I'm going to do is with the brick cleaner. In the brick cleaner is concentrated sulfate as HCl, that is hydrochloric acid, and we are going to titrate it or neutralize it using sodium bicarbonate. All right, sodium bicarbonate. So the sodium bicarbonate, what is the benefit of using sodium bicarbonate? Can anybody tell me? What is the benefit of using sodium bicarbonate? So in one of these, this is a volumetric flask, a round bottom flask. This is a round bottom, right? The bottom is round. Or you also call volumetric flask. So in one volumetric flask, I will prepare sodium bicarbonate, and in another volumetric flask, I will dilute the HCl. All right. So to not get confused later on, I put this sticker with the sign that it is the sodium bicarbonate, and sorry, not sodium bicarbonate, sodium carbonate, and this is HCl. Now let us go to that balance room to get the sodium bicarbonate. Right. So now I am bringing this thing. I need to use another funnel. Our lab assistant is not here, so I have to do everything. And I am moving, so you will see a lot of movement. So this is our balance room, and I am going to use this balance room for weighing sodium bicarbonate. My goodness. I have to go and find a space where I can put my phone. Right here. I hope that you can see and not feeling dizzy. Is there a better way that I can do to keep my phone straight or hold? Think. I need to go and bring the weighing bottle. All right. So any idea of how this is the weighing boat? This is a plastic boat that we use to weigh the solid sample, right? So I am going to use it here on this. I will take the sodium bicarbonate. First of all, I need to turn on the balance. and make sure that it's 0. So I put this weighing board on this surface. The weighing board measure 0.9 gram. I don't need this measurement, so I will make it 0. Now, altogether, it is 0. Including this board, it is 0. So I can just take the amount of sodium carbonate I need. So anybody have any idea how much sodium carbonate should I take? Hello, can you hear me?
Okay. Yes.
So any idea how much sodium carbonate can I take? Should I take?
2.5 gram.
Yes, good. From 2.5, around 2.5 gram, 2.5, 2.6, something like that.
Sir,
Yeah,
the volume has to be like a 2.5 to 2.8, right?
yeah, in between that. But why don't we care too much about why this is the range? Why not exactly 2.5, 2.55, 2.59, 2.63? Why not? Why it is a range? Can anybody tell me?
Yes.
So I have taken 2.68 gram. 2.68 gram. All right. So please, what we do is I will note it down here that I took 2.68 gram. And when you are taking it or doing this type of measurement, do not think that you will remember it immediately. Note it down. If you don't, you will forget later on. So 2.68 gram I have taken. Now I am transferring it. I don't know if you can see, I'm transferring it to this volumetric flask and this weighing board holding this thing. I'm putting it here, all right? A little shake, and then I will still wash this this weighing board, the plastic, wash down there to make sure that whatever gram I have taken, I will make sure that everything goes inside this volumetric flask. So I will wash it down. But I don't have water here and I have only 2 hands. So I'll come later on to take the cap. Let's go there to put the water inside. Oh, so any idea why we do not need to be very careful about what is the gram that we take?
Sir,
Yep.
we can't see your screen.
Really? No. Can you see?
Yeah, no.
Okay. So can you see the here now what I'm going to show? This one, my hands.
Yes.
Okay. So this is the weighing board. I measure the weight here. So I will wash it down. I will wash it down this volumetric flask like this. So that the 2.68 gram that I have taken is most hopefully, all is inside. All is inside. And another thing, I will wash down this funnel as well. So funnel is washed down, and I leave it here. So what I'll do is I will give a swirl to make sure that it dissolves. So it looks like that it is dissolved. No, not much solid left. I'll give a good swirl again. Make sure the rest of the solid dissolves in the water. I need to use the cap. Let me go and bring the cap from there. Okay, so I bring this cap, I put the cap there, and then good shake like this. Okay, don't invert now, just do this shaking like this, hold this, the round shape, the bulb shape, and then like just shake like this, so it will be shaken inside and they will dissolve. Okay, good. My question was, why we do not have to be very careful about this, the weight, the gram, 2.6, 2.7, I took 2.68. So why it is so? It is because whatever the weight I take of sodium carbonate, Na2CO3, I can find the number of moles anyway. So it does not matter 2.6, 2.7, 2.8, right? How do I find the number of moles? How do we find the number of moles from 2.68 gram of sodium carbonate?
Divide by the molar mass.
Exactly. Thank you very much, whoever you thought. I cannot see the screen, your name, but thank you. Yes. So since I can find out the number of moles anyway, so I don't have to be very much careful about the mass. But now anybody can ask that, oh, so I can take 4 gram, yeah? No, you can, but don't. Because if 4 gram or 5 gram of sodium carbonate, that means the number of moles increases and the concentration is going to high. So if the concentration is going to be high concentration, your titration will not be very accurate. Why it is not accurate? I will tell during when I do the titration. But if I forget, please remind. So I will make it up to this mark. There is a very faint mark here. I'm sure that you cannot see, but here is the mark. I have to make it up to this mark. Only then it will be 250 milliliter. Until here, no. It is not until here. It is until there is a very thin color mark, faint one. You have to say carefully, there is the mark here. Until that mark, it is 250 milliliter. Which is fill now. What I'm going to do is, I'm going to give a good shake so that it mixes everywhere. All the water that I added and the sodium carbonate I took, they mix all and homogeneously. Water finish already. Go and drink some more water. Okay, so now I make it the full. Let me give a good shake again. Okay, there are some bubble on the top, so I will wait for this bubble to subside. Only then I will see the clearer surface of, until where is the surface of the liquid, so that I will I will make it to the murk. So I will leave it for a while. By the time I can prepare the sulfuric, HCl. So how do I prepare the HCl? Can anybody tell me? First of all, I will take 5 milliliter of the HCl and then make it 250 milliliter. But still, to double confirm, this guideline or analysis of brick cleaner says that I should weigh this round bottom flask as well. So I'm going to weigh in the weighing balance room. So you guys hold on here, yeah? I'll come back. So this round bottom flask is 111.60 gram, and I am recording here 111.60 gram of this weighing flask. Now, what I'm going to do is I'll show you that the acid is given here. Otherwise, just give me the acid and go away. So here is the concentrated HCl. All right. And I am going to take 5 milliliter of it in this cylinder. And then I will transfer this 5 milliliter to this round bottom flask. So let me put my phone here, and I hope that you can see. Hopefully you can. You can see, right?
Yes.
Yes.
Okay. Why so tight? Oh, I don't know. Why so Oh, I cannot open this thing. Oh, I cannot open this. I'm going to call another lab assistant who is here. So you guys have to wait for a few minutes. Okay. I have asked her to come and she's coming, but I'm surprised why we cannot open. Anybody has any guess why we cannot open the HCl photo? Any idea? What could have happened? Why it is so tightly? Why it is so tightly? So, oh, open. Oh, it is very much highly tightly. I don't know why. But anyway, thank you. Okay, so hello guys, you're there? I mean, our students are there.
Yes.
Okay, good. Right. So what I'm going to do is I have already weighed this one 111 and 60.60 grams. So I'm going to take 5 milliliter of it, and it is so concentrated, this HCl, that you cannot see, but I saw just now that it was fuming. The fumes come out, the vapor comes out. It's very, very concentrated. I'm going to take 5 milliliter of it. Okay. Now this is the parallax error. That if I cannot see it properly, the line, then I will miscalculate the concentration as well. So I have to see it really closely. All right, so this is not 5 milliliter. This is 5.1 milliliter. All right, 5.1 milliliter. And remember this thing, that is 5.1 milliliter. I'm going to transfer this to this polymetric flask. And immediately I have to stop for it. First of all, because it is vapor coming out. Second, it's very concentrated, so it will take moisture from the air as well. Now, what? Okay. So I'm going to weigh it again, so that from the weight difference, I will know 5 milliliter is exactly what is the weight for 5 milliliter. All right. So I'm going to weigh it. So you guys wait here, not weigh. You guys wait here. I am going to wait in the balance room. Come back in a few seconds. Now I know that it is 117.3534 actually. 117.34 gram of the weight for including 5 milliliter of HCl. Now, why I'm saying that 5 milliliters, just now I was telling 5.1 milliliter, isn't it? Because when I was transferring from that glass to this glass, there is a loss, a very small amount of loss, but there is a loss. And usually in the analytical chemistry or any type of analysis, we do not want to lost anything. We would always take a very precise, very last, decimal places reading to make our analysis much more sophisticated, very accurate. But since we are human, we understand that when I am transferring one thing from this one to this one, there will be a little bit lost here because it will stick to the glass inside. I cannot 100% transfer. So that is why I'm saying that, okay, although it seems like 5.1 milliliter I took, but when I transfer here, it is roughly 5 milliliter I have transferred. Maybe a little bit more than 5, but it is, yeah, it is not 5.1 anymore. So I will consider it is 5 milliliter. 5 milliliter of HCl I have taken. So for 5 milliliter of HCl, what is the mass, the difference? 117.34 including HCl, and without HCl 111.6. So it is 5.3 gram, right? So 5.3 gram. It seems like this. Yeah, it's about that. You have to do the math, and then you'll find it's about 5.3, 5.4 gram which I have taken. So now, what do I do now? I will add water to make it 250 milliliter until this is the mark. And also remember that I said that there was some bubble to, so I left it. I have not put fill up to the mark. So I'm going to fill up to the mark for sodium carbonate now. Okay, so it is, now I can confidently say that my sodium carbonate inside this bottle is 250 milliliter. All right. So what I'm going to do is the same thing. I will add water to this concentrated HCl, but I want to do this inside the fume hood, because if I open the stopper, the fume will come out and I don't want to inhale that fume. So I'm going to do the same thing inside. Okay, so I have added water inside it, but it is not up to the mark yet. So I will give a good shake to make sure that all of the solution is actually mixed very well. And now I'm going to make up the, this is not a good one. Let me change another one. Okay, so another good shake before I reach to this mark. Make sure that it is homogeneous. Homogeneous means everywhere is the same. And now finally I'm going to make it to the mark. All right. Thanks to my skill that it is, I don't need to use the stopper, but your student will mostly use the stopper towards the end of that mark, because, you know, if you cross that mark or overshoot, some students say overshoot, so you do not know it's 250 milliliter or not. It's not 250 milliliter anymore. So yeah, that's why we have to be very careful about the mark. Now I'm going to do the, titration. Okay. So now this is the titration stand, and this is the burette. So in this burette, I will take this what do you call it, sodium carbonate, and then I'll take 20 milliliter from this acid in a conical flask to make the titration. Right. And in according to this manual, our lab manual, it says that I should take this 20 milliliter of standard sodium carbonate solution into our 100 set 1 plus aside as a control. All right, so this is actually telling me the opposite thing. It's either way. You can take this HCl here, or you can take sodium carbonate here. It will do the same thing, but I will follow this guideline that I have to use 4 of these conical flasks, and I will use this conical flask, 4 of it. And I'll take 20 milliliter of sodium carbonate in each of these conical flasks. Before I take, I give a good shake so to make sure that it's mixed nicely. Right. So I will use the pipette filler, right? All right. So 20 milliliter, I will pipette up. Okay. So I've taken 1. Taken 2. When we take using the pipette, there will be a little bit left at the top. Okay, do not force it to take relieve it into the flask. It's supposed to be there because of the structure of pipette. It is supposed to be there. What we can do is just open the valve here, because there are 2 valves, right? The pipette filler, one is for filling up, one is for releasing. So releasing valve, we will press and then touch this pipette at the bottom, so that whatever supposed to go out will go out. And there will be a left, still a little bit left, and leave it there. Don't force it out. Right. So 2 taken. Number 3 almost going there. Okay, good. Okay, 3 done. And then I'm going to do it number 4. Okay, 4 seconds. So I'm done with the pipette thing. So I'm relieving the pipette, leave the filler, and put the pipette aside. Need to clean it later. So many cleaning thing I have to do today. All right. So this HCl that I prepared, I will put it inside this burette, right? But before I put it inside the burette, what I'll do is, I do not know whether it is, I hope that is clean. I think the lab assistant is cleaned it, but I just want to rinse it with a little bit of the HCl that I'm going to use. So I'll take a little bit, maybe 1-2 milliliter in this, and then I will rinse like this to make sure that it is washed with this. There is nothing else there, and then throw that 2 or 3 milliliter. All right. So let me do that. I'll do it in the sink. So probably you cannot see, but I just have told you, right, how to rinse it. Okay, so it is rinsed, and I hope that it is clean. I'm going to fill it up. All right. So I've done it, and this, then shift the bit, therefore need to go handle. All right. So now the titration part coming. What I do? Can anyone tell me what should I do before I do titration? Start titration. Anybody has any idea or any suggestion? Hello guys, you're sleeping or what? I will put some of 1 drop of methyl orange. This is a chemical indicator. So it will tell me when our titration is going to be finished or going to be done. I'll put just 2 drops of this indicator. All right. So now you see that it is a little bit yellowish color, right? A little bit yellowish color. If you do not see it, let me show it. That this is the yellowish color, right? You can see. So now I start from the 0. The first reading, the first one, replicate. I start initial result, initial volume of HCl in the burette is 0.1 milliliter. Initial milliliter, final. Right? Number 2, number 3, and number 4. All right, so I'm going to do it now. I'll start adding drop wise. And then constantly shake it. Can you see my hands? Can you see the things that I'm doing? At the end of the titration, when the titration is done, all right, when the titration is done, it will change to pinkish color. Good. The color changed. I think I have added 1 or 2 drops excess amount. So you see the color is not the same anymore. It's changed to pink color. But I think I have added 1 drop more. That's why it's a bit dark color. So now I'll record the volume. The volume is 19.6. Final volume is 19.60. Now I do for the second one. Hello, can you see or hear me?
Yes.
Yes.
Okay.
Can still hear.
All right. So I'm going for the second to replicate 2 drops. I put of the indicator, and then again. Now the second initial for the second run. This is the second run. The initial is what I stopped for the beginning. So it will be 19.6. The initial reading is 19.60 for the second one. And I constantly shake it so that it mixes everywhere and nicely. It's going to be done. So I very careful now. Yep, change the color. And I'm going to wash down the small bit of HCl here at the tip. At the tip, there is a small bit I'm going to wash down. And if I even wash it down, does not change anything. It is number of moles are still same, right? And we are going to test the number of moles. The number of moles are still the same. So yeah. Now the color changes and it is 38.4. 38.40 is the second titer, needed. Third one, I'm going to do, I need to fill it up, sorry, I forgot. I need to fill it up because there is not enough for the third one. I have only around 10 to 12 left, but I need around 19, so I have to fill it up. So now I fill it up to 6.7. 6.6. 6.6. You don't have to make it to 0 because you know that you are counting it anyway. So you don't have to make it to all the time fill up to the bring and then make it exactly 0 now. You just make it, you just fill it up. So it is 6.6. So for me, the third run, the initial volume will be 6.6. Yeah, 6.6. 6.60. I start. I add 2 drops of the indicator and swirl it to make the color difference. You see the color, right? Color difference. And then I start adding. Right. And I constantly shake it up. Yep. Color changes. So now you see the color changes. So all are the similar color I have for all 3. And this one is 25.9. 25.90. So I think I have found almost similar all. The reading is like 19.5 and then 19.3, I think. So around the range is quite concordant. It's not exactly 0.1 difference, but it's quite concordant. If I had done it much precisely, then probably I would have a much more well result. So this is how we should be doing. And now the question that if I would take 10 milligram rather than 2.5, right? I took 2.5 milligram of sodium carbonate. If I had taken 5 gram, what would happen? Then it is 5 gram, means it's quite much number of moles are inside, and you would need maybe 50 milliliter or maybe more than 50 milliliter of acid to titrate, right? You can still titrate it. It will take a long time and lot of resources. And also the concentration is high. So you have to make sure that in everything, all of the solution is reacting at the same moment, at the same time. So there are quite main consideration. So I'm not going to do the 4th one because you got the idea, right? And it's quite, seems like it's concordant. So this is it for this titration. And now, after that, you have to do the calculation for the sodium carbonate number of moles. And from the calculation part, sodium carbonate calculation, you have to do the number of moles. How do you do? Just now somebody told. And you already know N equals C into V, right? And or M over M, molar mass. Calculate the amount of sodium carbonate in mole present in each conical flask. So from this number of moles, I have made it 250 milliliters. So I know the concentration of it, right? And then from there, 20 milliliter I have taken. 20 milliliter I have taken to each of the conical flasks. I have taken 20 milliliter. So I can calculate how many number of moles are each of these conical flasks I have taken, because in 20 milliliter, how many moles, right? We can calculate. Okay. So using this, the balanced equation I have to use, I can see from the balanced equation is 1:2 moles. So if 1 mole of sodium carbonate, 2 moles of HCl is required. So if I have, let's say, X mole of sodium carbonate in there, I will need 2 moles of HCl to neutralize this X. 2X mole I will need. So if I have 5 moles, I need 10 moles. If 20 moles, I need 40 moles of HCl because it is 1:2 mole reaction. So from there, you can also calculate the number of moles of HCl is required for each of these beaker for titration. In moles. So now we know the number of moles of HCl for question number D, calculate the amount of hydrochloric acid that we have, and find the percentage by mass of HCl in the brick cleaner. This is interesting. Percent by mass of HCl in the brick cleaner. How do I know the density? Remember that I took the HCl 5 milliliter and then I do the weight difference. And from there, I found the mass of 5 milliliter HCl. From there, I can find the density because density is M over V. The mass over volume, volume is 5 milliliter I have taken. So from there, I can find the density. So if I know the density for question number E in calculation, I can also find the mass of HCl that was in the original solution, in the undiluted, in the 5 milliliter of HCl, how many moles, how many gram of HCl is there actually. So we can find that one too. And then also, in the discussion and conclusion, the accuracy of your result, the mass of HCl you found from part 1, part A, part B, the possible sources of error, what could be the error. There are many things involved in the lab because first of all, I have taken the cylinder, right? Oh, before that, I should show you one. Hold on. This is a pipette. Okay, this is a pipette. I hope that you can see. And in this pipette, this is mark. This is 20 milliliter pipette. So this is mark. Until here, it filled up to 20 milliliter. But you see that, I don't know whether you can see. Can you see? Is this close enough? The 20 milliliter, it is positive negative 0.045 milliliter. So it has a tolerance that this 20 milliliter at 20 degrees centigrade. All right, at 20 degrees centigrade, this mark, until this mark, it means that this pipette will, the volume that you take until this mark is 20 milliliter, but not exactly 20 milliliter, 20 plus minus 0.045 milliliter, because this is the tolerance of the pipette. This is the tolerance of the pipette. So you take it, that doesn't mean that you have exactly 20 milliliter taken, plus minus 0.045 milliliter also you have taken. So this is a possible error that we have because I did not standardize it. I used it, I consider it's 20 milliliter, and I use it as it is. So ideally, I should have used, what do you call it, standardize it before I start. Also, same goes here for this burette. You see it is 50 milliliter, right? I don't know, you can see. So you see it's 50 milliliter here, it's written, but here after 50 milliliter, there is plus minus 0.1 milliliter, sorry, plus minus 0.1. So when I said, okay, 19 milliliter I added, actually it was 19 plus or minus 0.1 milliliter, right? So this is one thing that we should consider during our experiment. Same goes for the electric balance. In the electric balance that I just used at the beginning, it has a tolerance of plus minus 0.1 milligram. So when I say that, okay, I've taken 2.68, it is not exactly 2.68. It may be 2.67 or it also may be 2.69 plus minus 1.1. So this is the thing that we have to consider. And also this volumetric flask has its own tolerance as well. And this tolerance is plus minus 0.15 milliliter, 0.15 milliliter is the tolerance. So everyone has some tolerance in it. And yeah, you know that this thing has to be added up. So, and also parallax error. So probably when I say it's 19.1, probably it is not 19.1, it's going to be 19.15, 19.05. So I have my limitation of my eyes. So my eyes probably is not microscopic. Probably your eyes are better than mine. So you see better, but this is what I see, right? It is not my insincerity or not lacking of my seriousness, but it is my capability. So these all things added up to this possible error. So all this error can be added up. Systematic error and random. This is all are the random errors that can happen. Okay, so this is it for today. Do you have any question? Anyone? Hello?
Sir,
Yes?
will we be given the data for our
Yes.
experiment? Okay.
Yes. I'll be giving the data to you guys, just like the previous lab report. You please look up to your group in Canvas, lab group, so your data will be given there.
Okay, thank you.
No problem. Anyone else has any question? Hello?
No, sir.
Who is it? No. All right, so no question, yeah? Let me see who are there. Oh, Bilal, you are here, yeah? Quite early for you. Okay, so other question, and probably we can stop. So I'll see you tomorrow class. Chelsea says, sir, can you explain about the percentage by mass again? All right, percentage by mass. We understand how many moles of HCl here, right? It needed to titrate. In 20 milliliter sodium carbonate, it is 2:1 reaction. So if I have X mole of sodium carbonate, I will have twice X mole of HCl here. So from there, and that twice X mole is in 19 point something milliliter. So from there, we find out the number of moles of HCl, right, in this 250 milliliter. By that way, we can find calculation in 250 milliliter, how many HCl is there, right? So the number of moles of HCl is same in the 250 milliliter and in 5 milliliter as well, because that 5 milliliter I took at the beginning is actually inside it. All of it I took it. So the number of moles is same, but the concentration is different. The number of moles in 5 milliliter when I took it, then I can find the mass of HCl, right? Mass of HCl, number of moles. If I find the mass of HCl is easy to find. But another way that the density, we also know the density of HCl, 5 milliliter of HCl, the mass and volume we know because we weighted it. So from there, we also can find the density of HCl, and that density can be used to find out the mass of each 5 milliliter of HCl. So 5 milliliter of HCl, and let me try it out. What is the difference? I mean, what is the mass actually? 117 minus 111. 0.60. So 5.74 gram, 5.74 gram, 5 milliliter of ACL. 5 milliliter of ACL is 5.74 gram. So density is M over V, 5 over 5.74 over 5. So it is 1 point something, the density. Now, from if we find the density from that, so easily we can find the mass from here in that undiluted, sorry, in that undiluted, not here, in that undiluted HCl, or in a successive way that I find sodium carbonate here, number of moles, I find the HCl number of moles. So how many moles in undiluted solution, 5 milliliter, and from there the mass of sodium HCl, right? The mass of HCl from the number of moles we find. But in that undiluted solution, we already know at the beginning the mass, because 5.74 mass gram, right? So from there, we can also find this the mass in the original HCl. So original HCl, we undiluted HCl, the mass we find, and also the mass we find through this experiment. Whether these are same. If it is same, that is very good. If it is same. If it is not same, how much is the percentage of difference? So original in the 5 that was we done by the density that we calculated from density, original minus that one we find, we calculated, divided by the original times 100%. So that is the percentage of the difference. So that will be the error. We have the percentage of error that we have. Okay. Is this okay now?
Yes.
Okay. So any other question you have? No other questions. I think we can stop.